This is Chapter 8, Section 5. In this section, we will be solving proportions and other equations with rational expressions. So our objectives for this unit is to solve proportions, solve word problems using proportions, and solve equations involving rational expressions. All right, so basically a proportion is an equation stating that two ratios are equal. So if you said that I was driving 45 miles in 1 hour, well, that's a ratio miles per hour. An equal ratio would be if I drove 90 miles in 2 hours. So ratios compare two different things, miles to hours. And when they're set equal to each other like this, that just simply means that these two ratios are equal, or in other words, these two ratios are proportional. All right, so close to the beginning of the semester when we started looking at problems that basically showed a fraction equals a fraction, I told you guys one thing that will always work. If you have a fraction that equals a fraction, the easiest way to solve that is to cross multiply. So here we have a fraction equals a fraction. So that's exactly what we're going to do. We're going to cross multiply. So in my calculator, I'm going to multiply 35 times 4. I get 140 equals 2 times 7x is 14x. And then to solve for x, I divide both sides by 14. And so x is equal to 10. X is equal to 10. Okay, so that's part A. So part B, once again, we have one fraction is equal to another fraction. Or in other words, these ratios are equal, which means this is a proportion. So the same thing, we're going to cross multiply. So make sure we use our distributive property. So once we use our distributive property, 4 times x is 4x, 4 times 3 is 12, 2 times x is 2x, and 2 times negative 5 is minus 10. So now if you notice we have x's on both sides of our equal sign, so we want to get our x's together. So we're going to subtract the smallest x. So then I have 4x minus 2x is 2x. Bring down my plus 12. Those two 2's cancel each other out. So now we want our x by itself. So we're going to subtract 12 from both sides. And bring down 2x is equal to negative 22. And then the last step is to divide both sides by 2. So x is equal to negative 11. In other words, if we plugged in negative 11 here and negative 11 here, and we simplified these fractions, they'd have the same value. All right, number, or letter C, I should say. I have a fraction equals a fraction. So the best thing to do is to cross multiply. So I'm going to multiply 6 times x minus 7 is equal to 9 times x plus 2. So I'm going to use the distributive property. 6 times x is 6x. 6 times negative 7 is minus 42. 9 times x is 9x. 9 times 2 is 18. We're going to get our x's together by subtracting the smallest one from both sides. So 6x minus 6x cancels. Bring down my negative 42. 9x minus 6x is 3x. I want this x by itself, so I'm going to subtract 18 from both sides. That's gone. I bring down my 3x is equal to negative 60. And the last step is to divide both sides by 3. And x is equal to negative 20. Negative 20. So we have just solved those proportions. All All right, so you're going to have some word problems, and when you set up your ratios, you just want to make sure you put like things together. So this says, on an architect's scale drawing of a building, 1/2 inch represents 12 feet. What does 3 inches represent? So here we're comparing inches to feet in a scale drawing, inches to feet. So if I want 1/2 inch, I'm just go ahead and write that 0.5. That's 1/2, isn't it? So this is inch, 1/2 inch over 12 feet. And I find that when I label what the quantities represent, then it helps me make sure my proportions are correctly set up. So this says 3 inches. Well, where do I have my inches? On top or on bottom? Well, this is inches, so I have to put my 3 on top. And the question is basically, how many feet does 3 inches represent? How many feet? I don't know. So that's my proportion. So I have a fraction is equal to a fraction. So I'm going to cross multiply. So 0.5 times x is 0.5x. 3 times 12 is 36. And now I'm going to divide both sides by 1/2. So x is equal to 72. I'm pretty sure. I'm going to go ahead and put that in the calculator. Divided by 0.5. Yep, 72. So the answer is 72 feet. Because that was the question. All right, let's look at letter B. In a statistical analysis, Mike finds 3 defective computer disks in a sample of 20 disks. If the ratio is consistent, how many bad disks does he expect to find in an order of 2,400? So we have defective disks over a total. So that's what we're going to think of. So 3 defective, or I'm going to say 3 bad disks in a group of 20 total. So my second ratio has to be defective over total. So then it says, if this ratio is consistent, how many bad disks, I don't know, will he get out of an order of, or a total of 2,400? Okay, so that's what we're looking for this time. We don't know how many defective disks we have. It's important to, if you'll label each side, it'll keep you consistent, and because if you set one of your proportions up wrong, even if you do the math right, your answer won't be correct. All right, so on my calculator, I'm going to multiply 2,400 times 3, and I get 7,200 equals 20 times x is 20x. So now to get x by itself, I divide both sides by 20. So 7,200 divided by 20 is 360. So it says, how many bad disks or defective disks does he expect in an order of 2,400? So the answer is 360 defective or bad disks. All right, let's look at letter C. It says, on a map, each inch represents 12 miles. What is the distance represented by 20 inches? So for 1 inch, each means just 1. So 1 inch represents 12 miles. Then the question is, how many miles, or what is the distance represented by 20 inches? Well, 1 inch represents 12. So 20 inches represents how many miles? So if I cross multiply, I'd get 1 times x. 1 times x is just x. So I find on this one, all I have to do basically is multiply 12 times 20. And the answer is 240 what? Miles. So if you see inch, or excuse me, each, or per, that means for 1 inch, or per miles per hour for every 1 hour. All right, equations using rational expressions. To solve an equation containing rational expressions, first we're going to find the least common multiple of the denominators. We're going to multiply both sides of the equation by the least common multiple and simplify. We're going to solve the resulting equation. This equation will have only polynomials on both sides. And finally, we're going to check to see that no solution makes a denominator of 0. All right, so in our last section, we had problems like what's to the left of my finger and no equal sign. Or we had a problem like part B, only the left section of to the left of my finger. However, these are now equations because they're adding equal signs. So one of the things about equations is that you can cancel out all the fractions. Okay, and let me show you how we're going to do that. All right, so let's look at letter A. So before, when we didn't have common denominators, one thing you can always do to get a common denominator is multiply each unique denominator. Well, this x is already here, so I'm not looking at that. Each unique denominator is x and 2, so I'm going to multiply x and 2 together. So one way you can cancel out all those fractions is we're going to multiply each separate term by our least common multiple. So I'm going to multiply the first term by 2x, the second term by 2x, and what's in the equal, past the equal sign by 2x. Now look at this as an individual problem. If we were just multiplying those together, couldn't we cancel out those x's? Because this is basically like 2x over 1. So basically what happens is those x's cancel out, and all I have left is 2 times 3. My denominator's gone, so I have 6. All right, now if this is my multiplication problem, this is over 1 basically, so what cancels? Those 2's cancel, so what am I left with? 1 times x. So I'm going to bring them in my plus sign. 1 times x is x. And then when I look after my equal sign, well, I'm going to cross simplify. My x's are gone. And what do I have left? I have 7 times 2, which is 14. So now I want to solve for x. So I want x by itself. To get rid of positive 6, you subtract 6 from both sides. That one's gone. So x is equal to 8. And I've just solved that equation. I did this in the wrong order, I just realized, because it first asked to state the restrictions. So remember my denominators were x, 2, and x. Well, can I ever make a 2, 0? No, I can't. So the only restriction I have, since that is a single variable, the only thing that x could not be is it could not be 0. X cannot equal 0, and does it? No, it equals 8. So my answer is good. All right, so letter B. So remember when we had these problems earlier, I said if you have a trinomial and the other denominator is something like this, then I betcha that part of this answer is going to be 5 plus 2. I meant x plus 2, excuse me. So let's go ahead and tear this apart. What's two numbers that multiply to give me 10 but add to give me 7? Well, that would be 5 and 2. Oops, 5 and 2. All right, so if you notice, here's half of this one. This one has both of them, and this one has half of it, right? So we're going to multiply. So anyway, this is the least common multiple because it contains each unique factor. Okay, like this one here, each unique factor was 2 and x, so to get a common denominator, I multiplied 2 times x. Well, each unique factor, this one's not unique because it's here. This one's not unique because it's in this one. And so the only two unique factors is x plus 5, x plus 2. So, like I told you earlier, if there's an equal sign, you can cancel out the fractions and just end up with polynomials. So I'm going to multiply, I'm going to write this down here. Every single term, I'm going to multiply by our least common multiple. So there's a least common multiple times x over x plus 5. Okay, plus, I'm going to bring down I'm going to multiply my least common multiple by this whole term. And this whole term is 3x over x plus 5, x plus 2. Now my equal sign, I'm going to have this term, and I'm going to multiply this also by my least common multiple. So it makes it a long math problem, but it's actually kind of easier to do it this way because you don't like fractions anyway, so we're going to get rid of them. All right, so let's look at just this part right here. If this is a multiplication problem, what cancels? This matches that, right? So now we're going to distribute. We're going to multiply x times x plus 2. Well, x times x is x squared, and x times 2 is 2x. All right, and the denominator's gone because we canceled it out. All right, now we're looking at just this section in the middle. Well, what do you notice? These match perfectly. That cancels and that cancels, so all we're left with in this second term is 3x. And then finally, the equation, what can we cancel out? Well, we can cancel out this and this. So now we're going to multiply 2 times x, which is 2x, and 2 times 5, which is 10. All right, I'm going to stop for a second because I realized once again I forgot to find the restrictions first. So as soon as I broke this down, I should have gotten both of these unique factors and set both of them equal to 0. I should have said, okay, well, x plus 5, what's it going to take that to equal 0? And the other unique factor is x plus 2. So if I subtract 5, I'm going to find out that x is not allowed to be -5, or if I subtract 2, -2. So when it asks me for my restrictions, those are my two restrictions, -5 and -2. All right, I should have done that first. I forgot. Now I'm going to go ahead and finish this problem and find the value for x. All right, so this is a quadratic equation, which means we always want quadratics to be equal to 0. So we're going to have to move these terms over here, but first we have to combine these two terms. Or you know what, since this is 2x and I'm going to cancel this one out, let's just do that. Let's just get rid of those, right? Same thing. Same thing, if I added them, I get 5x, and 5x minus 2x is still 3x. All right, so I'm going to have x squared plus 3x. Since it's a quadratic, I want everything moved over so I can set this equal to 0. Well, that means I have to get rid of plus 10. I'm going to move it on this side of the equal sign. Well, does it have a like term? Nope, it doesn't. So part of my quadratic equation is minus 10. All right, so now this is a quadratic equation set equal to 0. So I want to know what two numbers multiply to give me -10, but add to give me +3. Well, this tells me that my signs are different, and this tells me the bigger number has a positive. So my two factors would be 5 and 2. The bigger number is positive. All right. So now that this is set equal to 0, I have to set both of these equal to 0 to solve for x. Well, if I'm going to subtract 5, that means x is equal to -5. Or if I add 2, x is equal to +2. So I've just solved my equation. Those are the values for x. Now, the last thing I have to do is go back and check my restrictions. So remember, we were supposed to do this first. To make sure that this is not an undefined radical expression, I have to make sure my denominator isn't 0. Well, if this was -5, this would end up being 0. If either of these were -5 or -2, this would be 0. And if I ended up with this x equals -2, that would be 0, and it would be invalid or undefined. So now you have to check your answers back with your restrictions. X is not allowed to be -5 or -2. So if you notice, my answer is -5. Well, because of my restrictions, I have to get rid of this answer. I've already told myself I'm not allowed to get -5 as an answer. My other restriction was -2. Well, one of my answers was +2. So this one is okay. I have to get rid of that answer because of my restrictions, which means the only answer, the only value for 2, or x, excuse me, is 2. In other words, if I plug in 2 for every one of these x's up here, when I add this value plus that value, I would get this value with a 2 in there. So I've just solved for x. Whew, that was a lot of work. All right, so all of these have equal signs, which means we are going to ultimately get rid of our fractions. We're going to cancel out the denominators. So the first thing we have to do on letter C is we have to look at every unique factor. Well, the 3 different things, either letters or variables I see, or letters or numbers I see, is 4, 7, and x. 4, 7, and x. I see 2 4s and I see 2 x's, but every unique individual number or variable is what I'm looking for. So I'm looking at 4, 7, and x. So I'm going to literally multiply those 3 unique factors. 4 times 7 times x is equal to 28x, which means I'm going to multiply every individual term by 28x. Did I say 27? 4 times 7 is 28. I'm going to multiply this first term by 28x. I'm going to multiply the second term by 28x. And behind the equal sign, I'm going to multiply this by 28x. All right, so think of these as 3 individual problems right now. All right, so how can I simplify 28 and 4? Can I divide both of those by 4? I can. So 4 divided by 4 is 1. 28 divided by 4 is 7. And then I have an x, so those two cancel each other out. And all I have left is 7 minus 9. You have the money? Okay. Love you. My daughter left. All right, so this very first term right here, I have 7 times 9. The denominator's gone, so I'm going to write 63. All right, let's look at the second term. It's a negative term. Once again, we can divide 4 and 28 both by 4. This time our x's don't cancel. So basically what we have is negative 3 times 7 times 21. What's negative 3 times 7 times 21? I mean, negative 3 times 7 times x. What am I saying? Negative 3 times 7 times x is negative 21x. And the denominator's gone. And finally, our equal sign, we can get rid of our x's. We can divide 7 and 28 by 7, and we get 4. So what's over here? 4 times 2, and we get 8. All right, we want our x by itself. So we want to get rid of positive 63. The only way to do that is to subtract 63. So we have negative 21x is equal to, in my calculator I'm typing in 8 minus 63, and I get negative 55. And that doesn't divide evenly. It's a fraction. So I am going to leave my answer. So first of all, do you realize I'm having to divide by negative 21? So since it's a decimal, I'm going to leave it as fraction form. But I got to remember that if I divide a negative by a negative, my answer is positive. My answer is positive 55 over 21. Okie dokie. Letter D. I have to take every unique denominator. Now, this is being held together with a minus sign. I can't separate this. You know, I thought of these as individual factors, which they are. This means 4 times x. So that's why I multiplied 4 and x and 7. But this is one whole factor. I can't divide that out. So these two denominators are the same, and this one is a 1. So 1 times x minus 4 is x minus 4. So I'm going to multiply every single term by my denominator, x minus 4. And this was kind of easy because these match, and since they match exactly, I get to mark them out. So what do I have left in this first term? Just a 4. This one also marks out. So what do I have left in my second term? Minus x. And then finally after my equal sign, I just multiply 1 times x and 1 times negative 4, and I get x minus 4. Oh, I forgot. Once again, I forgot to find my restrictions. This restriction is just going to be a 0. X cannot equal 0. Because if x is 0, 4 times 0 is 0. And if x was 0, 0 times 7 is 0. Now this, in order to find my restrictions, I would set my denominator equal to 0. And this time I'd have to add 4. So my restriction is x cannot equal 4. That's my restriction. Remember, you only take your denominator and set that equal to 0. All right, so anyway, we're going to go back here. Now we have x's on both sides, so we're going to get those together. We're going to add, to get rid of minus x, we add x to both sides. So this is gone. We have 4 is equal to 1x plus 1x is 2x. All right, so then we want x by itself. We're going to add 4 to both sides. So 4 plus 4 is 8 equals 2x. And finally, the last thing we would do is divide by 2. So x is equal to 4. So to make this true, all of the x's would have to be 4. But what does our restriction say? Because if I put 4 minus 4 right here, I would get 4 divided by 0, which is undefined, minus 4 divided by 4 minus 4 is 0. Does 0 minus 0, no, these aren't even zeros. These are undefined. So the answer for Hawks or your test, or, excuse me, I was about to write no restriction, but that's not right because we have a restriction. But the answer is no solution. Because we've already said, even though when we solved it, we got 4, this cannot be an answer. Because it would make our rational expressions undefined. So the answer is no solution. All right, we have really run out of room. So I'm going to get my paper here, and I'm going to solve this last one. So we have these two binomials. I bet you $100 this is going to be these two put together. All right, so let's see what happens. All right, think of two numbers. When you multiply, you get -2, and when you add, you get -1. This tells us our signs are different. This tells us the bigger number is negative. So 2 and 1, which number is bigger? 2, so 2 is negative. So does -2 times 1 equal -2? Yes. And does -2 plus 1 equal -1? Yes. So this is our least common multiple. And these are both repeated here, so we don't have to mess with these because here that we're just putting them all together. We're putting each unique factor together for the least common multiple. So I'm going to take my least common multiple, and I'm going to multiply every single term by it. That's the first term, okay? Well, if this was over 1, this cancels. And what we have left is x times x, which is x squared, plus x. And then that's our equal sign. All right, so now we take our common factor and we multiply it by this term, 1 over x plus 1. Well, if this was over 1 and it was right beside each other, I'm running out of room, so I had to squish it up here. Well, these cancel each other out, right? So what do we have left? We have 1 times x minus 2, which is x minus 2. And then finally, we have this term right here. So we'd have 3x over, and then if we multiply that by our least common multiple, we see that both of these cancels. So what do we have left? We have plus 3. All right, I did it again, you guys. I forgot to find our restrictions. All right, so let's go back to our original. We're going to take both of these unique terms for our restrictions. We're going to set them both equal to 0. So x minus 2 and x plus 1 equals 0. If I add 2, I'm going to find out that one of my restrictions is positive 2, and the other restriction is, if I subtract 1, negative 1. So I have to be careful. If my solutions are either 2 or negative 1, I have to go back and check with my restrictions. All right, let's go back to solving our equation now. So here's our quadratic, so we want to move everything over here, right? So first thing I'm going to do is simplify these two like terms. So negative 2 plus 3 is positive 1. So now I want to get my x's together, so I'm going to subtract this x from this x, and I find out that those x's cancel. And then finally, I want to move 1 on this side and set this equation equal to 0. So I'm going to subtract 1 from both sides. Those are unlike terms. So now how do I simplify this? Well, this is the difference of two perfect squares. So the square root of x is x. Square root of 1 is 1. Since that's the difference of two squares, one gets a plus and one gets a minus. And so, since it's set equal to 0, we have to set both of these equal to 0. And so, what are my solutions? My solutions are x equals negative 1 and positive 1. That's my solutions. Now, let's go back and check it with our restrictions. Well, this tells me that x is not allowed to be 2 or negative 1. Well, one of our solutions was negative 1. So I have to get rid of it. I'm not allowed to have negative 1 as my answer. So the one and only solution to this equation is 1. Now in HOX, if you put that negative 1, it's going to mark it wrong because it's already going to know what your restrictions are. So always go back and check your restrictions. All right, so here are your practice problems. If it's a fraction equals a fraction, like these are, make sure you cross multiply. This one is also a fraction equals a fraction. Now this one is not. Now if it was like that, that is a fraction equal a fraction. But since this is being added to something else, you cannot cross multiply. So you're going to, so for these, since you're cross multiplying, you don't even need common denominators, because you're cross multiplying. But these you have to have common denominators, which is 3x. This one you have to have common denominators, which will be 48. 8 times 6 is 48. Or a smaller one would be 24. You could use 24, but it doesn't matter. And then this